All right, so in this video, we are going to do an ARMA or an autoregressive moving average process. So an ARMA, autoregressive moving average process. In general terms, ARMA, in general terms, is going to have P many lags for the autoregressive process and Q many periods for the moving average. But before we get into the actual ARMA process, let's review the autoregressive process, general autoregressive moments, and then the moving average. So for an AR autoregressive, a P order autoregressive process, so P many lags, we get Y of T is equal to we use alpha. So our intercept, I'm sorry, not alpha 1, it would be alpha 1 of their first lag plus all the way to alpha P with our P lag plus our error term. So if we do the expected value, if we take the expected value of YT, this would mean it's the expected value of all of this. So the expected value of a constant is just a constant. And we can, of course, factor out all of our constants for the expected value. So factor out alpha 1, factor out all the way to alpha P. So give us our expected value of this P flag. And then the expected value of the error term is just 0, because remember, our error term is IID with a mean of 0 and some variance. So because this is a covariance stationary, because it's covariance stationary, this is going to be equal to mu. All of these values, all of these terms is going to be equal to mu because it's a constant mean. It's the first moment's constant. Otherwise, it wouldn't be covariance stationary. So this means that mu is equal to alpha 0 plus alpha 1 mu plus all the way to alpha P mu. So this means you can subtract all the terms with the mean in it, and then you can solve for the mean, which would give you alpha 0 divided by 1 minus the sum of our coefficients from 1 to P. So this is the expected value for our autoregressive P order process, or for the model. So now for the variance. The variance of YT would be equal to, again, the variance for the intercept is going to be 0. The variance for a constant is just 0. And we can factor out the constants for each of the Y terms. You factor out the a constant for the variance, it gives you the constant squared. So this means that it would be alpha 1 squared multiplied by the variance of Y plus all the way to alpha P squared multiplied by the variance of Y plus then the variance of our error term up here. And the error does have a variance, so that would be the variance of our error term. So now we can solve. And remember, the variance of YT is still going to be the variance of Y because it is because it's covariance stationary and it's a constant variance no matter what time is, no matter what T, no matter what the value of T. So now we can solve for it. That means the variance of Y is going to be equal to the variance of our error term divided by 1 plus our coefficients from 1 to P. So this is the expected value and our variance for an autoregressive P order process. So now, real quick, let's do a moving average. So remember, a moving average of order Q is going to be, we'll use Y again. So YT is going to be equal to theta 0 plus theta 1 of YT minus 1 plus all the way to theta Q times error of t minus q plus our error t. And remember, error t is IID with the mean 0 and some variance. So if we do the expected value of this, the expected value for all of these error terms is 0. So as t gets large or independent of t, because remember this is this would be stationary, and our error term is a 0 mean white noise process with 0 autocovariances for k 1 or greater. This means that the expected value of yt would just be the intercept, theta 0. And typically this would be equal to y of 0, which is equal to 0, but doesn't necessarily have to always be the case. So now for variance, for the variance of y, let me write the y a little bit clearer. For the variance of y, the variance of theta 0 is 0 because it's just constant, it doesn't change. So this would give us theta 1 squared, because again, you'd factor it out, multiplied by the variance of the error term, plus all the way to theta q squared, multiplied by variance of the error term, plus the variance of the error term. So this, we can factor this out. We can factor out the error terms and solve for the variance of y. So remember back from the previous slides, or this would be from the from a previous video. From the previous video, the variance for a moving average process, variance for a moving average process would just be 1 plus the sum, I'll use I again, of I equal 1 to q, for all of our theta squared multiplied by the variance multiplied by the variance of our error term. So this is for a general moving average process. And now let's put it all together for an ARMA, for an autoregressive moving average process of order P and Q. So this is for a general ARMA process or ARMA model. So YT, I use alphas again for the AR part. Alpha 0 plus alpha 1 times a y of t minus 1, so y with 1 lag, plus all the way to alpha p times y of p lags, plus, let's do a theta 1 times the error lag 1, plus all the way to theta q times error of t minus 2 plus our error t. So the expected value for this, notice that there is no theta 0. That's because there can only be one intercept. So our expected value for this would be the same as the expected value for just a normal AR process. And then now, because remember, our error terms are IID with the mean 0. It's a 0 mean white noise process. But now for the variance of y, this would give you, factor all of these out, all the alphas out, which would give you, I'm gonna do it with a summation. That way we can save some time. I use I index for the AR process. So all your indexes, or I'm sorry, all your coefficients squared, multiply the variance of y. There's p many, plus all of the, I'm sorry, I don't want to use I again. Let's use j, q many thetas squared, multiplied by the variance of of our error term. So this would be, oh, and then this would be for all the thetas, but then you have this one at the end. You have that one at the end, so then you'd have another variance of the error. So this would be the variance of the of an ARMA, of an ARMA process of order P and Q. Then you just solve for the variance of Y. So this would be like the second moment. And this is only if the correlation between Y and your error term is 0. So this is an ARMA process, and later we'll go over how to do this in Python. But in the next video, we will get into a random walk, and we'll get into testing for a unit root.